All right. Good morning, Science 10. Today we're starting a new topic, new unit. We're going to be taking a look at forces. We're going to be beginning to look on gravity. So forces, we're at gravity today. Out of forces comes the idea of work. And there is a special definition, a physics definition of work is. So we'll get into that in the next few days. And then we're going to talk about energy. And energy can be pretty important. We talk about conserving energy and using energy and so on. But all of these are connected together. Forces get it to work, work gets us to energy. And then we're going to be talking about uh, potential energy and kinetic energy in particular. And can't spell today. That's okay. So this is sort of where we're going in this unit, and this is really in the area of physics. And we might get into the idea of nuclear energy as well when we get out of working with some of these things. But we're going to be doing some calculations with these things, and so having a Casio FX260 solar is definitely going to be to your bidding or necessary. All right, so we want to begin with the force of gravity. And really, we're taking a look at how the Earth, or we're dealing with that the Earth attracts objects to it. Uh, that's what keeps you on the ground. The Earth is attracting you. So, I mean, here's the Earth, here's you, you're running and you're smiling, but it's the earth that is pulling you down towards this. So we have this force of gravity that holds you against the earth. And so you go running around the earth, you can jump up, and the earth attracts you back down, and you land on the earth. And it's because we live in a gravitational field that this gravitational field is all around us and keeps us attracted towards the earth. You can think about it, well, what if there was no gravitational field? Then we go to jump and we go sailing off the earth. That would not be a good situation. So when we talk about the force of gravity, that's going to be equal to or proportional to the mass of the object. And we have to have a unit in here or a constant in here that allows us to calculate or the relationship between the force of gravity on an object and the mass of an object. Because you know that if you're out walking and you see a pebble, then you can reach down and you can pick up that rock, no problem. But if there's a bigger rock, there's more mass. So this is a small m. This is a large m. And if you were to come and try to pick this up, you're not going to be able to do it. There's a greater force of gravity here than there is here. So small m, small force. Let's use capital letter. Large M, large force. It's only Superman who'd be able to pick up these things up, faster than the speeding locomotive, able to leap tall buildings in a single bound, and so on. So let's talk about how we're going to use this equation. So let's talk Fg is equal to mg. Now, I was noticing that I actually don't have this equation in your data booklet. So you might want to add that into your data booklet. Yeah, sort of we're adding to this. So we're going to have Fg, which is our force of gravity. And whenever we measure force, the unit is newtons. And the symbol is capital N. M, that's our mass in kilograms. And then we have little g. Yo, little g, it's a rapper, physics rapper. Sorry. This is what we call our gravitational field strength. Our gravitational field strength. This is not, sometimes students start calling this gravity. I really do not want you to call it gravity. Call it gravitational field strength. Your mind, your mouth is able to say that. And it has a value that's equal to 9.8 newtons per kilogram. That's what the value is. This is what we call a constant. And a constant doesn't change. So while you're on Earth, this is the value of our gravitational field strength, little g. Right, so let's make use of this, how we make use of it. And that is really what we're going to do today, is making use of this formula and working with it a couple different ways. So we can say, well, what is our force of gravity for a 15 kilogram block? Let's call it a box. All right. So we know our formula is F is equal to mg. That's always going to be there. You can write this down. It's not a problem. So we have these three things linked, F, M, and G. Now we can say, well, what information is given to us in the question? Well, we read through the question. We have this 15 kilograms. Information that is important to us is generally there as numbers. So we have 15 kilograms. Well, what is that? That is a mass. We always measure mass in terms of kilograms. And then, is there any other numbers in here? No. So what are we looking for? Well, this F. So we're wanting to know what F is. But the formula that we have, F is equal to mg, this doesn't talk about g. So we need to understand, well, g is a constant, and that's equal to 9.8 newtons per kilogram. That's always going to be true, and that's what we're going to use. So the question will not necessarily include this, but you need to remember that this is there as part of the work. All right, so now so first of all, I want you to summarize the information. I want you to write out the formula. Then we're going to substitute in the information. So F is equal to M. Well, M is equal to 15 kilograms. And we have G. Well, G is equal to 9.8 newtons per kilogram. And so then you're going to pull out your Casio FX260 Solar, just grabbing mine here, and go 15 times 9.8. And so this is going to be equal to, force is equal to 147. 147 what is the question? Well, we're talking forces here, so the unit of that is going to be newtons. And so there we have our first answer. F is equal to mg, substitute in the values, calculate it out. Let's do another one. We'll make this a little bit harder. What? What is the force of gravity on a 500 gram mass? All right, so we're going to go through a question. We're going to identify numbers in our question. So we have this 500 grams. What does that represent? Well, that's our mass equaling 500 grams. Is there any other numbers in the question? No. We have this FG. Don't worry about this little arrow. This is a Physics 11 thing. I just did it by I forget to do it in physics, and then I do it here. So let's go FG. That's our question. That's what we're trying to find. All right. Is there any other information we need to know? Oh, sure. There is our value of G. What's our value of G? 9.8 newtons per kilogram. Okay. So our formula, Fg is equal to mg. So we're going to substitute in our values. Well, our mass, but our mass needs to be in kilograms. So how do we change 500 grams equaling how many kilograms? All right. Gotta get the K in there. To do that, what we're going to do is we're going to take, well, there are 1,000 grams in a kilogram. Kilo represents 1,000. So we're going to move the decimal place over 3 places. 1,000 has 3 zeros. We move our decimal place over 3 places. And so 500 grams, that would equal 0.5 kilograms. 500 grams is half a kilogram. So then we can go Fg is equal to our mass, that's 0.5 kilograms. Well, our value of G, our G is 9.8 newtons per kilogram. And so we're going to go 9.5 times our 9.8, and that will equal 4.9 newtons. That is the force of gravity on a 500-gram mass. Let's do another example. But here we're going to ask a little bit different. So we want to know, what is the mass when the force of gravity is equal to 650 newtons? Okay, so first step when we approach a question is to take a look and find values within our question. Here we have 650 newtons. What does that represent? Well, that's our force of gravity. All right, any other number in the question? No. So then we need to ask, what is the question asking? It's asking for the mass. Okay. Is there any other information we would need to know? Well, we remember hold on, this is the force of gravity. So we're going to have G, and that's equal to 9.8 newtons per kilogram. All right. Well, let's write out our formula. Fg is equal to mg. We're looking now for our mass. So that would mean that we would have to do some algebra to change this over. So we would have to divide both sides by g, and that would tell us that, well, g divided by g is equal to 1. Just like, 4 divided by 4 is equal to 1, 16 divided by 16 is equal to 1, x divided by x is equal to 1. Here, g divided by g is equal to 1. So we have our mass then is equal to our force of gravity, scratch the arrow, divided by our gravitational field strength. And so then we can put in our force of gravity. Well, that's 650 newtons. And we're going to divide that by our G, which is 9.8 newtons per kilogram. And that's equal to 66.326536061. So we could say 66.3 kilograms. That would be our answer. But sir, I'm not really very good at this type of algebra, moving things around. All right, so here's what we can do. We can, let's create a triangle. we're going to create a triangle that looks like this, 3 squares in there. And we're going to put our FG up here, and we'll go M and G in here. Okay. So now if I create an object, I want that filled. There we go. So now I can move this around and I can cover things up. Okay. So here we have, this is a little way of working things out. If we want to, the way this works, we put the F on top, M and G on the bottom. If we want to know what the force of gravity is on an object, well, we take this and we cover up our force of gravity. Now, if I was doing this at school, I would just use my hand and cover that up. Here I have M and G. They're side by side. So that means that this is M times G. In this question, the question was we were wanting to know what the value of M was. So if we use this and cover up our M, then we see that what we have is our Fg over little g. That means division. So we have a force of gravity divided by the gravitational field strength. And so just by, we can work out, we don't have to do the algebra if we want to work out how to do our calculation. We want to find the force of gravity, that's M times G. If we want to find the mass, that's going to be the force divided by little g. If we went to a different planet, the gravitation there would be different. Like if you go to the moon, the force of gravity on the moon is 1/6. And so if we wanted to know what the gravitational field strength on the moon was, well, we could take, well, what's the force of gravity on a mass, a certain mass, and that would tell us what the value of little g is. On Earth, 9.8. And we can calculate the force of gravity, calculate the mass, or we can calculate the force of gravity. All right, let's go on. Let's do another quick question. What is the mass when the force of gravity is equal to 18.2 newtons? All right, so if I was to come back, well, first of all, let's go through our steps. What is the mass? We have this 18.2 newtons. What does that represent? Well, that's our force of gravity. We'll label that. Anything other numbers in here? No. Then it says, what is the mass? So mass is what we're looking for. That's supposed to be a question mark. There we go. Mass is what we're looking for. Is there any other piece of information we need to know? Yes, we have a gravitational field strength, which is 9.8 newtons per kilogram. All right, how are we going to set this up? Well, if we set up our triangle FG, MG, and let's do a heart. Oh, isn't a heart nice? And so now if we take our heart, if we want to calculate the force of gravity, we're going to go M times G. If we want to calculate our mass, we're going to go Fg divided by G. And so that's what we're going to do. So our M, that's what we're trying to find, is going to be our force of gravity divided by our value of little g. So that our force of gravity is 18.2 newtons. Our gravitational field strength, well, that's 9.8 newtons per kilogram. And so I go 18.2 divided by 9.8, and that's equal to 1.857142857. Let's just go 1.8. Okay, so if you learn the, you're always taught to, if you're rounding from fives, you're going to round up. So that would be 1.9 kilograms. Okay. It's not meant to be hard, meant to be quite straightforward. And I'm going to give you a worksheet, and the worksheet will take you through and ask you some questions, and there'll be some solutions for it as well. All right. Talk to you again soon, and thanks for watching. Live stream is ended. Stop live stream.